Okay, welcome back to the deep dive.
Hey there.
So today we're digging into the sources you sent over. We're tackling something pretty fundamental in math, but maybe a bit different from typical algebra thoughts.
Right.
Linear inequations in one variable.
Yeah, exactly. And looking through this material, it really jumps out that we're not talking about your standard equations.
Not x equals something.
Oh, no, not like x equals 5. It's about these other symbols. You know, greater than, less than.
The greater than or equal to, less than or equal to ones too.
Those ones. And they're not about equality at all, are they?
No, the sources make it clear they describe a relation. Or maybe a condition.
A condition, yeah. How one thing stacks up against another, bigger, small.
Something like x is less than 8. That's not one specific answer.
Not at all. It's saying x can be, well, any value that fits, anything under 8.
It's describing a whole range.
A range, exactly. That's the key idea here.
Yes.
A whole region of possibilities.
Okay, so that's the mission for this dive then. Really get what these linear inequations are about.
Mm-hmm.
And crucially, how we find that range, that set of answers that
Yeah.
works.
Right, finding the solution set. And, starting off, the methods feel pretty familiar, like equations.
Yeah, you can add things, subtract things from both sides.
Move terms around just like usual. That part feels like, home base.
But then comes the twist. The part that apparently trips people up.
Ah, yes. Multiplying or dividing. Specifically by a negative number.
Okay, what happens there? It's not the same as with equations.
Not at all. If you multiply or divide both sides by a negative, that inequality sign, it flips.
Flips.
Okay.
You mean like greater than becomes less than?
Exactly. And less than becomes greater than, the whole relationship reverses.
That feels weird.
Mm-hmm.
Because with an equation, multiplying by -1 just changes the signs on either side.
Mm.
The equal sign just sits there.
Right. But here, if you have, say, -2 by 10,
Okay.
and you divide by -2, you don't
Right.
get x5.
No.
No, you get x5. The sign flips completely.
Wow. Okay. You flip the script.
You do, because you're basically reversing how the two sides relate. If A was bigger than B, then A is smaller than B.
That makes sense when you put it like that. Okay.
And there's something else in these materials that's just as important. The replacement set.
The replacement set. What's that?
It's the pool of numbers you're even allowed to choose your answer from.
Oh, right. Like, are we talking whole numbers or decimals or?
Exactly. And it changes everything. If you solve something and get beat B3,
Okay.
what numbers are actually less than 3? Well, it depends. If your replacement set is only natural numbers, like 1, 2, 3.
Then your answers are just 1 and 2.
Right. But if it's integers, you can include 0, -1, and so on down forever.
Or if it's real numbers, then it's everything. Decimals, fractions, everything below 3.
Everything.
Yeah.
An infinite smear on the number line going downwards from 3. So the type of number allowed is fundamental to the actual solution.
So the replacement set kind of defines the playground you're finding answers in.
Perfectly put. And visualizing helps too. The sources talk about using a number line.
Yeah. With the open circles and closed circles.
Mm-hmm. Open circle if the endpoint isn't included for strict less than or greater than.
And a filled-in circle if or equal to is part of it, so the endpoint counts.
Exactly. It makes that whole range idea much more concrete visual.
Okay, so let's recap the main takeaways from the sources then.
Mm-hmm.
Inequations. They're about ranges, conditions, not just one fixed answer like equations.
Right. A set of possibilities.
Solving them starts familiar, but the big watch out is multiplying or dividing by negatives.
That flips the sign. Gotta remember that.
And maybe the most subtle part, the replacement set. What kind of numbers are allowed totally shapes the final answer set.
Absolutely. Natural numbers, integers, real numbers. They give different solutions to the same inequality.
That sign flip rule really is the standout aha moment, isn't it, compared to solving equations?
It's the classic mistake to avoid. A small rule, but huge consequences for the range you find.
And realizing the solution isn't just the inequality itself, but also the kind of numbers you're allowed. That's powerful too.
It shows context matters.
So thinking bigger picture for a sec, where else, maybe for you listening, in your work or life, do you run into constraints or conditions? Situations where you're not finding one single number, but figuring out a range of what's possible or allowed.
Yeah, like project deadlines or budgets or resource limits, maybe. It's that same kind of thinking.
Definitely something to think about.
Hope this dive into the material gave you some useful insights into linear inequations and how they frame possibilities.